Okay, let's treat this question like a double slit interference pattern question. So you have the two slits separated by a distance d, and pretend that there's a screen here. So you're going to have bright and bright fringes on this screen. So now we have a satellite that travels along this line. So this satellite is going to detect maxima, minima, maxima, minima, maxima, and so on. Okay, so how do we make use of this information here that a satellite is traveling at speed v? So I guess we can write v to be equals to distance divided by time. So the distance will be the distance between two maxima, and the time will be the time taken for the satellite to go from one maxima to the next maxima. So what will be the distance between two maxima? That would simply be the fringe separation, right? So the fringe separation, of course, follows the formula L lambda over D. But in this question, the screen distance is given as h. So L lambda over D. D is the slit separation, which is the distance between these two radio waves here. So that's going to be D. Next, what is the time taken for the satellite to go from one maxima to the next maxima? The question says that the satellite detects f maxima per unit time. So let's say the satellite actually detects, say, 4 maxima per second. If the satellite goes through 4 maxima per second, then how long does it take to go from one maxima to the next? It'll be 1 divided by 4, right? So the time would actually be just 1 over f. So now let's put this thing together. This means that we can write v to be h lambda over d divided by 1 over f. So speed is distance divided by time. Rearrange this equation, you're going to get the wavelength to be equals to dv over hf. Alright, so that's the answer. Ta-ta!